So here finally is the finished toilet flush button. Let me show you. So this is the final button. The heart-shaped, which is a little joke, turned out to be a lot smaller than I anticipated, than I wanted. Basically due to the fact that the lever this button pushes on worked very well, and I didn't want to change the geometry of the lever and the axle, and a bigger button just didn't fit. It would touch the edge. So the lever was working perfectly, so I decided to go with a smaller button, and unfortunately it had to be quite a high button, otherwise it would just disappear below the edge. So the button is very good, the lever is also very good. This is a little cover covering up the mechanism, and this is the original front plate of the original manufacturer, and it had to go with a little spacer. I will show you later. It's just an edge spacer. So let me show you the flushing movement. So the interesting part here is that you see it's a two-action movement. So when you push it in, it goes up a little bit. That means the lever, the other part of this lever behind this axle, is coming down on the plunger, but the plunger of course is still down. And when finally all the water is gone and the plunger comes up, due to some kind of very interesting vacuum motion or suction motion, and it finally pops back up, then finally the button comes all the way back up. So it's very interesting. So while this plunger is still down inside the reservoir, you cannot do anything to it. You just have to wait until it wants to come up. The slightest friction or whatever blocks it from coming up. So it's been quite a hassle figuring out how to do it. Leave the plunger untouched and have a very smooth, without friction, an axle and a lever mechanism. So that turned out to be quite the feat. So I still have to fix it. Well, this cover can rotate, but it's quite tight, so the tolerance is a little over tolerance, the diameter. So I made the diameter, increase the diameter in steps, printed a new part. Well, it finally will snug fit into the diameter of the existing front plate. So let me take this out. Let me take this off. So here you see, this is the spacer. And the interesting part is here, there's a little hook for the front plate to hook over. And here there's a little part that fits, it clicks underneath. It clicks underneath the front plate protrusion. As you see here, there's these two little notches. Slips right back, so it cannot. So you hook it up, and there's two little notches. Make sure that it doesn't. You can't lever it forward. So the walls are the most important thing of the design. They have flanges that go on the existing holes for screws. Still have to fix the screws, but it works even like this. It works. The trick is to make it very without any spacing. Make a very tight fit of these side walls. And then here you have the axle. And you have the lever mechanism. Go on the axle. And yeah, it's been working for a couple of months already. And of course the interesting question is how fast does it wear out? But because it's just PLA. So far it's working great. Now here you see the lever action with a little rope pulling up the plunger. So it actually pulls up the plunger, and when the water reservoir is empty, and when you release the button, this is the first action, and then when the water is out of the reservoir, the plunger comes down and pulls up the lever. Let me show you. It's very interesting. So, pop, this is action 1. Wait, boom. There it goes down, and the button's up. The slightest misalignment of where you pull the plunger, or the slightest touch of this lever mechanism, you see there is a space between here, blocks the plunger from going down. It's stuck. And you see a little tape I put there because the ropes tend to release from this cavity they're in. So I used a little tape. Sorry about that. So this is working absolutely better than I thought, and I'm very happy with the design. I'm quite proud of it. I will keep you posted on the wear and tear of this. And the trick to do a faster design is rule number 1, don't think. First model your fixed environment. Model this cavity. I should have modeled this cavity first. And then you can assemble your design in 3D. You can see if there's any intrusions, overlapping parts. You can see how big the gap is. You can see the alignment of the lever. And if you do it in iterations by just trying it and fitting it, it will take you 10 times longer. And then the rule number 2, of course, is print it in your bulk color. I have a bulk color white. I have a lot of white. I always print it in white because you have to print it 5 or 6 times. And once you're happy, you can do it in your color. I plan to use like pink or purple for this little heart. So that's a rule. And basically, I will keep you posted on how it lasts. But this was Print the World. Feel free to copy and improve if you can. Good luck.